I want to continue to work on my report while you watch over my shoulder. And we're now ready to begin with the analysis section. I'm going to first go back to the description for a moment, because in the description, we should clearly lay out what we are going to do in the analysis section. No, we shouldn't talk about specifically what figures we're going to make, what statistics we're going to do. What I mean by lay out what we're going to do is we need to specify what the research questions are or what the variables are that we're going to be working with. So we know that there are 3 different parts to this analysis. We know that because we planned it all out right at the beginning. So notice how I lay out these 3 different parts in the description. I state, first, I will study the composition of SES in the sample. You may recall that we stated that that's one categorical variable, and so we talked about the graphs and statistics for that. I will then address the main purpose of this study by comparing reading scores for different SES groups. That was also part of our plan. And finally, I will see how SES is related to ethnic groups as a means of potentially explaining why reading scores often are found to differ among ethnic groups, as shown in past studies. So these are the 3 different parts, and we already planned out for each of these parts based upon whether the variables were quantitative or categorical, and how many of them there were. We figured out what we would need in terms of graphs and statistics. So now let's do it. So the first thing I said I was going to do is look at the composition of SES in the sample. So that's how I start my analysis. SES is divided into 3 categories, low, medium, and high. I do not know the definitions the original researchers used for these classifications, but now I move to figure 1, and notice I reference in the narrative figure 1, which means I now have to have a label or a caption stating figure 1 and telling what it is. This is going to be bar plots with the proportion of the sample of the 200 high school seniors in SES classifications. So coming down here, within the script, I am annotating what I'm doing, and I'm doing that by using the hashtag. What a hashtag will tell R when we're writing a script is ignore what comes next. This allows us to create comments without confusing R. Anything we put after a hashtag, so I have a hashtag and then a space, and anything I put after that within this script, and remember it's a script because it's between these 3 apostrophes here and down here. This is all called a code chunk. So rather than this being text in our notebook, these are commands for R. And the hashtag says this is not a command, it's just a comment. So the comment says I calculated the frequencies. Notice I use the table function for that, using the student's data set and the SES variable within that data set. Okay, so if I have in my environment students and SES is here, then I can do a table and that will give me frequencies called SES counts. That's a name I made up, SES counts. Okay? If I want to actually see what's in SES counts, I can go ahead and run that one line. Let me run just that one line. I'm going to click on Run and say Selected Lines. And now you'll notice in my environment I have a new variable called SES counts. And if I look at that, I'm simply going to type this in the window of the console right here, SES counts. There are the counts, 47, 95, and 58. Now I'm going to use these for a bar graph, but if I use frequencies, then I'll not be able to compare this bar graph very well to any other bar graph from a sample of a different size. So to put everything on a scale from 0 to 1, I'm going to turn this into proportions. Notice how I do that. I use the prop table function with ses.counts. ses.counts, remember, is where my frequencies are. That's this table that I just showed you. So now let me run just this line. What I did right there was I held down my control key and hit enter. If you have a Mac, there's another command, but if you pull this down and see run selected lines, it will tell you over here what the shortcut is. So I just used the shortcut. Now if I look in my environment, I see I now have a new variable created, ses.props, and if I go ahead and type that in, I can see what's in it. Low, middle, and high, but this time it's giving me proportions. And now finally I get to what I was trying to do, and that is to make a bar graph. So I'm going to use this bar plot function. I'm going to give it my table of proportions, and then I'm going to give it a couple other things. I'm going to, first of all, tell what to label the X or horizontal axis. That's going to be SES groups, and so I put that as XLab equals SES groups. That stands for X label. For my Y label, YLab equals proportion. And this is a funny looking command here. Let me talk about that just a second. In fact, let me do this. Let me run it without that first, and then we'll come back to that. All right, so I'm going to run this bar plot command, and here we go. It created a bar plot for us. Now this is fine just as it is, but if you want to tweak it, if there's anything you want to do, and there's all sorts of things we can do. We can create different colors. We could create little diagonal lines through the bars if you want, different kinds of shading. Lots of things we can do. There's just one thing I'm going to tweak here. I never like it when the vertical axis does not go as high as my highest bar. I need to go up a little bit further. It looks like I need to go up to about 0.5. So in order to do that, that's what that other command was you were seeing here. I'm going to add another, actually it's not command, they're called arguments. This bar plot is a function, and everything that is within parentheses are called the arguments of the function. So for this, I'm going to put in an argument called ylim, which means the limits of the y-axis. And those limits are going to be from 0 to 0.5, but we have to do that in a series of numbers called a vector. And every vector that we use in R has to be formed using the concatenate function, which is just C. So I'm using C from 0 to 0.5. Okay, now that will change my axis. Now if that all sounds confusing, you can ask your friends in the class who had the first semester with me, and they'll tell you it was confusing to them at first, but then they get very used to it, having to form these vectors with the C or concatenate function. Remember that you're going to be able to take this exact same script that I'm showing you and just tweak the variables for your purposes. So if you end up needing to expand it from 0 to 0.7, all you'll have to do is come here to this 0.5 and change it to 0.7. You're not going to have to do anything more than that. So you'll be able to tweak my commands fairly easily. All right, so let me rerun this. And now you can see the axis is extended above the bar, which I prefer. Now, if I had come to this code chunk and clicked on this little green arrow here, it would have run all the commands. So there it just reran them. And in fact, if you go up here and see, you'll notice that it reran SES counts and reran SES or reformed SES counts and SES prompts. And then here's the bar plot command. So everything you're seeing right up here in what we call the console window or pane is all what just ran. And then the bar graph is output right here. Remember that I also had clicked on the gear icon and changed it to show output only, which is reflected in this echo equals false, which we don't have to memorize because we can use that gear icon. So that's it. I've basically calculated those frequencies and created a bar plot. Now let's do some descriptive statistics to go with that. So here what I've done is I've taken the ses.counts. Let me type it in again here to remind you. There they are. I've taken the ses.props. Here they are. Whoops, I spelled it wrong, so I get a little error message. Now I spelled it wrong again. If I spell it wrong a third time, just warning to you. If you do it the first time and you get an error message, fine. You do it the second time and you get an error message, fine. If you happen to make the same kind of error a third time in a row and hit return, so if I, for instance, had spelled it like this and then hit return, you don't want to do it 3 times in a row, because what that will actually do, R will actually go inside the chip of your computer and it will overheat some of the circuits and it will melt them down. In fact, I've even seen physical fires started just because of typing in errors 3 times in a row. So be very careful to only do no more than 2 errors in a row, okay? No, I'm not telling you the truth. If I were to do 3 errors in a row, it will just give me another error message, and it will keep doing that until I finally get my act together and do it right. So you don't have to worry about burning up your computer. Okay, so back to line 82. I now use this function cbind, which stands for bind together in a column. So I'm taking the frequencies and the proportions and binding them together in a column, and here's what we get. Look at this. Here is now the column that I have bound together. Now, right now, I have this set as include equals false, which is why you saw this in the console instead of underneath. Let's look at this. It says show nothing, run code. That's not what I want. I want to show the output. So let me switch it to show the output, and now the output appears here. And that's what I wanted. So when I look at my preview, by clicking the preview button, I now on my preview have a little introduction. Don't ever start with just a table or graph without some words. A little introduction. Then the graph that I refer to as figure 1. Then the table. And this table should be referred to as table 1. So I'm going to have to fix that. I need to go back here and indicate table 1. Oh, now I see why I said do not include any output here. Look at this. When we only have a few numbers that we're going to refer to and we're going to do it in the narrative, we don't need a table. So if I go back to what I was doing, change it to say run the code but show nothing, X out this table, and now run and show nothing, and now preview, now it makes a lot more sense. I have my figure, and then without having a table, I start with some narrative. The sample consists of 23.5% in the low SES, 47.5% in the middle SES, 29.0 in the high SES, and I got those right from the console window right here. So your choices when you're reporting statistics, if you have only a few of them, I recommend putting them in the narrative and don't worry about a table. Later on, you're going to see where we have more of them that will put it in a table. So we've now completed one of 3 parts of the analysis. In the next video, we'll continue with the second part of the analysis.